So once again, thank you for attending. Today's session is a two-part session, which we'll talk about in a little bit. There's a lot of information to be shared about smart manufacturing, and you really can't do it all in one session. We thought we'd break it up into two sessions, but in both sessions, we will have a manufacturer on board who will be here to comment and talk about their own implementation. Some introductions before we get started. We have with us from Juergens, we have Kurt Schron, and Kurt is the Senior Financial Analyst at Juergens, has a multitude of experience and with other companies, and started his career as an industrial and systems engineer. We also have as a speaker, Rick Earls from Team Neo and the Smart Manufacturing Cluster. Rick is the Senior Director of Industry and Innovation at Team Neo, and also 25 plus years of experience in manufacturing, international trade, and started his career as an electrical engineer. And I think we'll go ahead and continue on. So today, as I mentioned, it is a two-part webinar, excuse me. There is a lot of information to share. Today, the first session will be a little bit of a 75-25, where we'll talk a lot about smart manufacturing, the basics, indoctrination, make sure we're all using the same terms and definitions. We have the same picture about data-driven manufacturing. And then the second seminar, which will be a week from today on May 25th, that part, we can go ahead and move forward on the screen. That part will be primarily a discussion with Kurt at Juergens, and he'll talk a lot about what it's really like as a manufacturer to implement a variety of different strategies within the plant. And probably one of the most difficult things is, where do you begin? And they'll talk about where they began and some of the processes that they put together to help each of us so we can start that same journey. And with that, I'm going to transfer everything over to Rick Earls.
Erica, do you want to say a little bit about Team Neo first?
Sure, thanks, Rick. So my name is Erica Fitzpatrick. I'm the program manager for industry and innovation at Team Neo, and I spend most of my time working with our innovation clusters, including our smart manufacturing cluster. So we are excited to be sponsoring all of the innovation type webinars for this year for Manufacturing Works. And we're excited that we have Rick presenting on smart manufacturing today, and then just a little bit about our cluster. So we aim, for those of you who are unfamiliar, we aim to be the platform for all things smart manufacturing. So we will amplify the manufacturing blueprint that will be coming out in the next couple of weeks through Magnet, and then just providing resources for manufacturers across Northeast Ohio to implement innovation into their companies and help increase jobs. And you're going to learn all about what smart manufacturing can do for you. So I'm going to hand it back over to Rick. Thanks, Rick.
All right. Okay, before we jump into the slide, I just want to give a quick overview of the reason we put this content together. So experience has given us that many of the manufacturers are reticent about implementing smart manufacturing. Again, it seems like a formidable task. Distractions, it's a distraction, at least typically, from making and shipping product. It does take time to go into it. Typically, nobody on the staff is an expert in all the different technologies that are related to smart manufacturing. Everybody, and typically senior management is always concerned about how disruptive the implementation would be. And at the end of the day, the question, like Ron had posed, how does a manufacturer get started with the implementation process? And so this The way that we put this first part of the presentation together was that we pretty well mirrored what Juergens went through, and that being Kurt went through with Juergens, the process they executed and used to implement the process they put in place. Actually, they even, in fact, found a vendor, a solution provider that helped them with their implementation. And then the process they used to, in fact, find that solution provider. And also the process they went through to learn the fundamentals and go through the indoctrination. So we're trying to mirror that now, all right? With that said, now let's go to the slide here. The reason this slide is here first is many manufacturers want to know why they should be listening to these words of wisdom that we're providing. In other words, what is possible? What is going to be the ability to improve business performance, efficiency, and drive growth? And this is a pretty well a telling slide of exactly what most manufacturers can expect. For example, it says increase overall throughput by 10 to 60%. These are typical numbers. In fact, they're provided to us by Hitachi. Reduce scrap rate 10 to 50%. Reduce machine outages 15 to 90%. Reduce accidents and near misses. I'm sorry. And so these are all the kind of things that manufacturer could use to justify going after smart manufacturing. Again, so that's why we put it in. Next slide. Now, let's start with a common definition of what manufacturing is all about. And I'll let you read that. Go ahead and read the example definition. The smart manufacturing are systems that fully integrate. And then there's another one from again, a consulting group, major consulting group. Smart manufacturing is likely the ability to solve existing and future problems. Those are, when you read those, are sort of nebulous for a typical manufacturer that's a small to medium size enterprise. Then let's take a look at even the circle. So this is a typical definition that you pull off the internet. It's ubiquitous on the internet. So it looks like there's autonomous robots there. There's simulation, systems integration, Internet of Things, cybersecurity, cloud computing, additive manufacturing, augmented reality, and big data. All that, I can assure you, most manufacturers I talk to do not have anybody on staff that has any insights into all that different, those different facets. So again, that's an intimidating and non-functional definition for most manufacturers. So what we're going to do is give you some another way of handling this and getting a little bit more intuitive about the definition. So let's go ahead to the next slide. So what we're doing is adding a concept called data-driven manufacturing to the definition. And in fact, as is shown there, the data-driven manufacturing actually is the infrastructure or the platform necessary that allows then all those different technologies to coexist in a solution. And this is really where most manufacturers should be spending their time understanding what's implied there. And let's take a look at what we're talking about. Data-driven manufacturing, as I said, is a foundational concept that underpins smart manufacturing and provides the infrastructure used by all the technologies around that circle to improve manufacturing operations. So again, it's linking all those different capabilities together. And DDM also establishes the manufacturing environment where all the critical assets used in the production process are connected to a data network so they can talk to each other and so they can share the data with management. So that's the big area. In other words, I'm taking all my critical assets, hooking them together with a communications network and making sure that I can freely exchange information between them. And that includes the things like even the workers themselves. Not only I consider a worker a critical asset then too. All right, so we're calling this a more functional definition. So one of the other things I wanted to do is also clarify some terms. Well, one of the things we always we discuss is that, or at least many of the manufacturers I've talked to have an issue with, they're worried about many of their assets are older and in fact don't even have the ability to communicate. Well, that's not really a big an issue now. We have a number of different vendors that are part of, for example, a cluster that have abilities to address those issues. So that doesn't hold anything back. We will focus on applications instead of technologies, and I'll talk a little bit about that in a few more slides. But again, the reason we are emphasizing that, it makes it a whole lot easier to justify the implementation of smart manufacturing when you talk about applications. And we'll get to that point later. Smart manufacturing and Industry 4.0 are interchangeable, at least the way the US and their relationship with Europe, the way they handle these terms. Industrial and Internet of Things sometimes used incorrectly to describe a complete smart manufacturing system. IIoT simply refers to a smart industrial device that can interact with the internet. All right. And so a number of manufacturers become, at least when we've talked to them before, have been, have wondered why we talk about connecting all of our assets to the internet, giving them all internet addresses when that's not necessarily required. And so this takes care of that. Also, for our purposes, we will focus on the production side of the business. In other words, focus on continuous improvement in manufacturing and leave the product / customer service side of the business for another time. All right. And one of the other terms, can we go back? Okay, one of the other terms I wanted to also reflect on is something called digital transformation. So, and I'm sure that's a concept you've heard a lot of and a label you've heard a lot of, but in the instance we've got here, so the digital transformation plan is another term used to define the DDM implementation plan. So for our purposes, they are one and the same. All right. Now we can go. Now, let's talk about the data-driven manufacturing a little bit. Just, we can talk about this is a simplified architecture of what we're really talking about. So you can see that there are boxes labeled with all sorts of things that reflect a typical manufacturing implementation. So the first box you also see there is this network of all these different boxes are all interconnected and frankly end up providing the data for that first box, whether it's an ERP system or a business intelligence system or a manufacturing execution system or a CRM system. All the data that's created from all these other boxes are in fact available. And then that first box, again, ERP, BI systems, MES, they are and have the ability to actually also interact with the other bi-directionally. So there are other functions that are referenced there, like a data historian. In other words, what do you do with all this data that we're collecting now from all of these different assets? We have a smart device and an asset. The big thing there is that we have data, again, bi-directionally flowing between the network and the asset itself. And we also have KPIs, key performance indicators, that have been designated at each one of those assets and help us indicate the actual operation of that asset, what it's doing, what its health is, what we need to also provide when we're trying to do our analytics to figure out exactly how the disparate assets do in fact interface with one another. And then, as I said before, we have smart legacy assets. We can actually, again, instrument any asset and make sure that it has the ability to interact with this network. Then we can also see there's smart nodes of automation, things like robots, for example, are there. And again, data is free flowing between them. KPIs are being indicated or have been identified. If the KPIs don't come directly, again, key performance indicators come directly from the machine, the controller itself, we can always add sensors to those machines to get things like, for example, I want to know what the bearing temperature is, or I want to see what the vibration signature of a bearing is, that kind of thing. We can always add stuff to that machine to have it fully functional within and provide support for applications that are important to us. So also emphasizing, there's also the human machine interface, HMI there, very important in the implementation again of this data-driven manufacturing. You have to be, it's almost worthless to have all this data flowing back and forth unless the information is being presented to those in the process that can react to any of the anomalies that don't make sense or need corrective actions right away. So that, again, the human machine interface is key to making sure your frontline workers, and for that matter, all those, even the supervisors, all those have the information they need to make decisions right at that moment that decisions need to be made. Access to the internet and cloud, of course, is always integral to most of the networks that are associated with smart manufacturing. And again, same thing with them with regards to the data the data network interchange, that being both data and KPIs. And of course, so not only is there a wired connection for the internet, but there's also wireless connection. So a lot of smart devices actually communicate with the network through a wireless link. And for that matter, any of the cloud access typically goes, in fact, through a wireless link then too. So again, this is a typical infrastructure. And the reason I put this up is because a lot of manufacturers are intimidated by the fact that no matter who you're talking to, or at least any number of organizations you're talking to, there's so many different protocols. There's so many different gateways that you have to worry about. There's so many different things like APIs that you have to worry about. Bottom line is, this is the general way a manufacturer should be thinking about what their needs are. And we're going to be talking about solution providers in a few more slides that can help them interpret their needs. But this is the level this is sophistication that is the minimum sophistication you need to have to be able to make a decision about how to implement data-driven manufacturing. Again, leave all the other details and things like that to solution providers that can help you through this process. So the key operational data is, take a look down there, it's collected, stored, processed, and optimized, all right? And support for continuous improvement applications is also provided by this architecture, all right? Kurt, you want to talk about Microsoft's Power BI tools and app suite then?
Sure. So, I mean, there's a lot of, that's how we have used a lot of our data-driven manufacturing, is utilizing Microsoft's Power BI and Power Platform. So all those different boxes you just pointed out there, Rick, point data into a data warehouse that we would have, and utilize it. So anybody from supervisors, people on the floor, management, all have their different reports and apps through the Power Platform that they can utilize and see one consistent set of data, one single source of truth, that everyone's looking at the same data sets, the same data that's refreshed continuously, always up to date. And then from an application standpoint, we have built applications, again, on the Power Platform that can read and write data back. So we use our ERP for everything. We try to use our ERP for as much as possible, so that again, it's one single place so we can know where all the data is. It makes our warehousing and our architecture a little bit easier. But there's always going to be places where you're not using your ERP fully. Couple examples for us, like maintenance. So maintenance on our systems, our ERP has a system, but our maintenance techs, to make them log into our ERP, find all the different places in our ERP that they need to clock in, clock out, do the different work that they needed, was a little bit cumbersome and challenging, because that's the only thing that they would need to use the ERP for. So we were able to build a simple app with 3 buttons, 3 clicks. They started, something that that's down, a machine that's down. They clock in, clock out, can keep track of everything they're working on. And also, when a machine goes down, our supervisors can use that same application to let them know that that a machine's down. They get a text message, they get an email, and all the information that they need to know to decide whether they need to stop whatever they're doing and go work on that machine, or keep doing what they're doing and then go over there later. So lots of different ways to use the Power Platform. I think told other people, everyone's application, everyone's implementation of that is probably going to look different. But I think it's a really powerful tool for almost any organization.
All right, sounds good. And you mentioned some applications. So again, it's quite evident that the value from the smart manufacturing realized only through applications. In other words, as this diagram shows, we do monitor the technology, the smart manufacturing technologies do have a way of, again, playing in that system, the data-driven manufacturing system, but all that information is fed into applications. And then it's the applications that take that and process that information and turn it into useful information, to improve business performance and efficiency and growth. So again, we're introducing another level that you need to be more focused on is applications. Remember that I also originally said that we were going to be talking more about applications and how they help us justify putting the data-driven manufacturing in, and how they help us interpret what smart manufacturing technologies do to provide value. So, and it's much the same as the smartphone. Again, or anybody who's done, for example, a Ring, put a Ring security system in. You've got a number of smart devices, like a camera that's also got the ability to communicate, and then you hook it to your network. I don't have to know much about the network at all. And then I have a whole slew of different applications. They have one, but they have sub applications that then allow me to look at all the different secure areas within my home. And again, I'm not a rocket scientist. I don't need to be that educated, or at least that familiar with those kind of technologies to be able to actually utilize a fully comprehensive system and put it in place myself. And much the same happens here again, even though most of the smart manufacturing technologies were very sophisticated and I don't understand them, at least as a manufacturer. I do know that I can get help now, figuring out how those then drive applications, because frankly, applications are where most manufacturers know what they're doing already. Those are the timeless items that are always part of the process, the operational process for manufacturing, and always will be. And frankly, the different technologies are just what's capable today that we use to go ahead and satisfy those applications. And we'll talk a little bit more about that then too. But again, the smartphone is the same way. Again, that smartphone is not worth anything unless you've got applications in it. And once those applications are in it, my life is much more succinct. I'm able to do many of the things that I need to, for example, banking and For that matter, I can talk to my phone. I'm sorry, I can talk to my my car. I can talk to my appliances. I can talk to the the heating system, security systems, all that kind of stuff is now available. And the same situation is applicable to exactly what manufacturers would go through then too for smart manufacturing. Again, applications allow you to harvest that value. Okay, next slide. Now we're revisiting that slide we saw from before. So again, harvesting value from the implementation of smart manufacturing, it's the impact of applications. So took that same diagram from before, for example, again, the increased overall throughput by 10 to 60%. That application, if you notice, in fact, those two top boxes are considered the application that is commonly referred to as operational efficiency. So these listed here are popular, some of the top popular applications that you can use for data-driven manufacturing or in general for most manufacturing. So operational efficiency, predictive maintenance. Again, if I can reduce downtime on my machines, that's again predictive maintenance. Look at how much more, again, the ability to improve the efficiency of the businesses, and for that matter, even operational efficiency, because they actually interplay. Same thing with work and health, worker health and safety. That is also a popular application, again, requiring the ability to monitor workers, pull information from them, interact with them. So that's how you're able to actually achieve those for example, 10 to 80% improvements in the business. Other popular applications are, in fact, one of the most popular is OEE, or overall equipment effectiveness. And that is made up of 3 different components. Again, how fast the machine is operating, and it's of course how fast it can operate as compared to how fast it is operating. The available uptime on the machine, and actually how much time I'm really using, is the next component. And the last and third component is quality. How many good products am I making? So you put them all together and you can come up with a way of actually monitoring or affixing a performance criteria to all my critical assets. So again, that's one of the more popular ones. You'll see that most people start there, most organizations start there with data-driven manufacturing as their first application of sort of more of a pilot project. And then they eventually, as they gain experience with that and find, again, more data starts flowing, and I then understand that I can use this data for other things, other applications, then typically I go into things like quality control. I add vision systems, for example, and go into quality control and get them to do almost immediate, instantaneous recognition of good product. And if I have any anomaly that shows up at any point, I instantly know when that takes place, so I don't make any more offensive products. Then we've got things like inventory management, supply chain management, and here's the big one now is cybersecurity. All those are popular apps for, and what's necessary to be part of a typical smart manufacturing system. So let's go to the next slide. So, so before I jump into this a little bit more, Kurt, what was your justification process when you put yours, when you actually implemented your smart manufacturing, or at least in fact it was the data-driven manufacturing system?
Yeah, so we made a decision that we were going full into this, and so we looked at what we could do in terms of what our expectations were from implementing additional data. And I think that the biggest value for us was just being all in the cohesive benefit of all being all in on that. So we all looked at data, we all looked at what we were going to be doing, and then assigned people to be in charge of those different things. So having that in place really, gave us the confidence to go forward. And then from a ROI standpoint, we were looking at just continually improving. So if we got 1% better, we were good. So we just keep trying to get 1% better. So that's kind of where we looked at it from a justification standpoint. And then as we continue to do that, we're look to invest more and more in other areas where we think that investment will bring back, positive ROI.
All right. Now, the other question I have for you then is, now, depending on what application there are a different set of KPIs associated with each one. When you first initially put your data-driven manufacturing in place, you were doing asset monitoring. Did you end up having to go to did you have to go beyond those KPIs that you were originally taken from the machines, at least at this point in time?
I mean, I would say that we did. I don't think we would have to, but I think that, as you go on this journey, you start to see, whatever your initial goals were at the beginning, they keep growing. So that's kind of what happened for us. Initially we were looking at making sure keeping a high uptime for our machines. So how can we increase our uptime on our machines? So that was kind of the goal for us. And we certainly have done that. And so now it's translated into a lot of those different things that you mentioned here, like quality control. We want to make sure while we're increasing uptime, we're also increasing quality. And so while we have uptime on those machines, are we using it effectively in terms of operational efficiency and different things like that? So while we started with uptime on machines as our number one KPI, it's definitely translated into multiple more as we keep expanding.
So as we look at this chart here, again, I put the popular applications across the top there. Are you starting to spill over in some of those other applications with other departments within your operations? In other words, maybe somebody's like you said, you were looking at quality control, but is somebody then looking at some of the operations, or at least some of the information that's flowing between the machines and all that, to do a better job of maybe inventory control?
Yeah, I mean, absolutely. So, I mean, again, I lump Power BI into, our data-driven manufacturing. So it's not connected to a machine necessarily, but it's pulling data that is connected to machines and is throwing that data off there. So our inventory practices leaders have access to Power BI. They're using that continuously. Right now, supply chain is an issue, getting raw materials in, and should we be looking to do something based off of those things? So Power BI is linked all 100% from top to bottom through those different things. So while one person's looking at it through Power BI, another person's looking at the same information, maybe in a different way. And so being able to combine all those different insights is really powerful.
So it sounds like you're touching on most of those applications listed here across the top. Then again, operational efficiency, certainly. Quality control, you've already mentioned that you're doing more in that area. Then predictive maintenance, how far have you gone in that particular application? So
we're certainly in preventive maintenance. I think, okay, with predictive maintenance, it's really a long journey on its own. So we're definitely in preventive maintenance and working with to just decrease that lead time as much as possible from when a machine goes down to when we can get it back up.
And it sounds like you've already done some stuff with the inventory management. Are you doing any closer relationship with your supplier, your supply chain?
We've certainly discussed it with certain raw material suppliers and things like that. So passing forecasts back and forth to be able to, increase our demand, increase what we get. We've, decreased some of our lead times and different things like that. So it's definitely something that we use as a communication tool with our suppliers for sure.
All right. And then with regards to, how about cybersecurity or worker health and safety? What did you do for the pandemic, for example?
So in the pandemic, we were, an essential manufacturer that we spaced out shifts. We spaced out employees. We sent, most of the office people home for a while, and then we were able to come back in for the most part when many of our workies late last year, and then but we have large machinery for the most part, so we were already relatively spaced out and socially distanced, but we certainly extended shifts. We had some people work only on the weekends, just to again, spread that out even more. So we definitely do that from a health and safety standpoint. And cybersecurity, I mean, is something that, is very important, and we utilize a lot of service providers to help us with that, to make sure that, and, Power BI, again, I keep going back to it, but it's a Microsoft ingrained product that has data and security, from the start. So it's kind of a core feature of it, which was nice.
So, so in your particular instance, you actually used, I guess it was Memex and forgot the other company, to actually put that physical structure in place that allowed you to start extracting data. And once that data was available, then you used the Power BI to actually utilize it and harvest value from it.
Correct. Yeah.
All right, sounds good. So let me go into this chart then a little bit further. As I was explaining before, the relationship between the smart manufacturing technologies and applications are pretty well laid out here. You can see that, for example, an autonomous robot plays a role in multiple applications. But if I'm trying to justify the use of a data-driven manufacturing, the actual value is harvested at the application level, because now I can do, again, you saw that, and even what Kurt was saying, that's where the performance improvement comes from. That's how it manifests itself. And then if we do some things, Kurt was talking about just a real quick process for justification, but you can also do things like ROI. That allows you then to justify the effort that's necessary to put the system in place. So that's what this chart is all about, just showing how you're going to be most probably. I know a lot of organizations talk about let's implement AI, for example, or let's implement IoT. If they only do that from a technology standpoint, they're going to be disappointed in the outcomes. It's only until you translate that through an application that you get the full impact of what's really truly possible with a smart manufacturing implementation. So you can see that we put down there the technology infrastructure to support applications is really those technologies. And then you harvest the value from the data to support the applications. All right. Any questions about any of this so far? I don't see a lot of people raising their hand or asking anything. Okay. All right. So let's move on to the next. So I also mentioned that one of the ways that Kurt and Juergens went about their processes, they went through a couple different phases. First of all, they did a readiness assessment. We were able to do that with them, that being Team Neo. They did a readiness assessment. Then the next phase was they did this indoctrination, which is much of the information you're seeing today. They were able to then get that passed amongst their senior management. Then they use that information then to go ahead and work with some SMEs, some subject matter experts, to then go ahead and define a pilot project. With that definition of that pilot project, they were able to put a requirements document together that described what they were looking for. And then they used that to shop around for solution providers that could help them out in the implementation of this data-driven manufacturing. And from that, they used their own criteria to do a filter, a reduction to a single candidate that then helped them. And that, I think that was, again, Memex was the partner they chose to go with, and then went with implementation. And Kurt, how many, you're what, 2 years into that implementation now?
Yep, about that.
Okay. And so how much of a key role did Memex play then with regards to realizing what you originally had defined as a requirements document?
I mean, so they did everything that we, looked for them to do. And so I think when you go back to like what you were talking about before in terms of the applications and things like that, they are a partner to get us the data. Again, I think that to me, this all comes back to a data-driven manufacturing journey. Once we have the data, then you still need someone to analyze that data or act on that data, whether it's coming from that system and they're giving you the pings and the alerts and things like that, or if you're doing analysis on that data. But there needs to be at least somebody to do that. Internally, we like to talked about the IS triangle, information system triangle. So it's got three corners of business process, people, and technology. And so if all you're doing is updating the technology, the people and the business process don't change, you're not going to get the value like you were talking about. So the people need to use the technology within their business process to really drive, value. And so those things are the keys when we were talking about upgrading our technology or doing that kind of thing. And so from that perspective, Memex was the key to upgrading our technology. At the same time, we had to upgrade our people and their business processes to use the new data to make it more efficient and effective for us.
All right, good. So let's go to this slide. So how to start your journey to data-driven manufacturing. You don't need, if you walk away with anything from this presentation, it's that first bullet. You don't need to be an expert in all the technologies. You just need to know what you need to improve your business and get help interpreting or asking what technologies should be put in place to support that requirement. Again, the applications, how to realize again the value from that data that's being collected. So what we're suggesting is find a solution provider partner to guide you through that process. And the reason we talk about solution providers, actually, we're blessed in this region here in that we have, realized that oil and gas started in our region, rubber and plastics basically started in our region, automotive assembly with big time. All these different, segments, manufacturing segments, all required some pretty advanced control. So we actually have a supply chain in place right now with all the different organizations that are here to support those types of industries. In fact, we have a local MEP that's our rep in this region is Magnet. Again, that's a manufacturing extension partnership. They've been around for 40 years providing these kind of services that allow you to, as a manufacturer, to go after these advanced capabilities so you can take advantage of them. And so you don't necessarily have to have all that background first. You work with these solution providers. They'll introduce you to all the different advancements that you need to realize the visions that are possible. And the other thing we have here in terms of, we talk in general about solution providers, but solution providers can fall into, like I said, like an MEP, but automation houses, as they've actually progressed to a point where they're just not providing, control cabinets. They actually go beyond that and have engineering backgrounds, and in fact understand, for example, data-driven manufacturing can help you with the implementation there. Same thing with engineering houses. We've got some great ones in this area like Seaford, and for that matter, Rovsys, which is the second largest systems integrator in the world. And we have systems integrators, of course, in this area that can work. We even have IT houses that started out in IT, but now have expanded their capabilities into being able to support operational technologies. In other words, any of those things that are being used for industrial control in the operations in the manufacturing side of the business. They're now capable of handling both of those scenarios. And many of them are also very good at now cybersecurity. So especially any of those manufacturers that have some component of defense-oriented business in their portfolio, they know they have, at least since last year in September, now they have to also come up to speed on something called CMMC, which is the next cybersecurity requirement for, again, the government be able to maintain your contracts. And at a minimum right now, they've asked most every one of those suppliers to provide a self-assessment of their ability to address CMMC. So, and just to let you know, most of the organizations, most manufacturers I've talked to don't understand the NIST standard well enough to actually do that by themselves. So they really need the help of, again, solution providers. We also have even software development firms that can help you out. For example, one of the best organizations I know of that know their Microsoft Power BI suite and portfolio is Vision 360. And a lot of the things that a lot of the manufacturers are utilizing to put some of these applications in place, they already have libraries that were created to support some of these different functions because they've got such a diverse customer base in manufacturing that a lot of this stuff already exists. So when you finally get to that point as a manufacturer, you don't have to repeat, you don't have to reinvent the wheel, you don't have to repeat what's already been done. They can help you get to you the end result as soon as you can. And they can also make it easier for you then at that point to take your time finding people to bring on staff. You still want somebody who's responsible for the implementation, but actually bringing people up to speed, getting them trained while they can be all part of that. Again, these solution providers can help. We also, and I'm sure a lot of you have also worked with the automation control vendors. We've got a very well established, like Rockwell, and for the matter, ABB, it's got a great presence here. We've even got some smaller organizations like Machine Tracking, they can easily help you very quickly do asset management right off the bat. And within, half an hour, you'd be up monitoring and pulling data from that application of a machine. So we have a very diverse background of organizations that can help you implement smart manufacturing. You don't have to internalize all this yourself. And not only do we have solution providers, but we also, and again, experts in industrial automation have been around forever, but we now also have, again, an economic development infrastructure ecosystem that's here to help you with the rest of the implementation. For example, once you've put a project in place and you want to scale it, we have the ability to come in, work with you, find funding, to do training, even help you adjust maybe even the organization itself, find appropriate people as you expand and add capabilities. Where would you find the next data analytics or data analyst to bring in, that kind of thing. We can, all of us together can help you get to a very effective data-driven manufacturing implementation very quickly. And as is shown here, wait a minute, I gotta get something that just came in and there. I couldn't see the slide. So the last thing I wanted to show you there is this model we have. Typically, we're talking about a 5-step process that starts with, first of all, we identify an application we're going after. In other words, what's the low-hanging fruit? So you need to do a preparation. Then you find the hardware sets you want to put in place. Then you connect things. Then you do visualization. In other words, how do you get this information? You're collecting this information, you process, and how do you get it back out to the line worker and supervisors? Then the next step is to analyze, see if you can recognize any relationships between that data that you've been pulling in, and find unique situations now that allow you to do a better job of controlling your process. And then go into optimization. That's where things like AI and data analytics and big data all play roles. But again, you can work with solution providers to at least initially get a hold on that. And then as time goes on, you'll actually, your internal staff will be able to pick up the slack and take you even further into your into the future, especially when it comes to continuous improvement. And you would do the same 5 steps typically for each one of the subsequent applications you're going after. So the other thing that you want to take away from here is this is really a long-term relationship with the resources that surround you in this region. All right. So Kurt, what reflects on your implementation effort? So everything I just described to you, how much of this actually maps well to what you've done and implemented in place? For example, staff, did Mimics actually help you for a while, and now you've basically picked up the capability of doing your own, for example, analytics? You say you've got the people that are pretty well up to speed on Microsoft BI now, for example.
Yeah, but I mean that we grew that internally. I mean, that's the journey. You know, we started out with a couple people and then expanded to a few more people, and we just expanded even more to, you know, allow people to start creating their own reports and some different things. And so it's kind of really a journey, you know, from how we can progress and how we can utilize it. And we learn, you know, as we're going along too. But I mean, I think to me, an important thing is to always, even if you're leaning on solution providers initially from consulting or that kind of hours, is have some people, or at least one person internally that is in charge of taking the action, because you can get all these insights, data, pretty charts and graphs and things like that. But if there's nobody to take action upon what you're seeing, it just falls to the floor. So it's really important to at least have somebody identified internally that can do that.
All right. All right. All right. Next slide, please. Is there a next slide? Oh, there you go. So as I described to you before, so this is generally the process that we described throughout this presentation that basically Jurgens used to put in place. So take a DDM readiness assessment, staff meeting to identify companies' needs and potential application pilot project is the next one. The third step, develop a DDM requirements document for a pilot project. The fourth is shop the requirement document to 3 or more potential solution providers. We can help you find solution providers that have the background that map well to your requirements document. So don't let that hold you back. Review proposals for the solution provider, then down select to that candidate. Using, again, the manufacturer makes up their own criteria for that. And work with solution provider on a detailed data-driven manufacturer implementation plan. Blend results into the company's strategic plan and engage in implementation process. So again, Kurt, want to say something about that, especially that last bullet there? Do you now take this activity and blend it into your strategic plan and act on it on an annual basis?
I mean, I think it's probably even more than an annual basis. I mean, we try to really integrate this into our culture of, you know, data. We're using data to make decisions. And so whether that's, you know, which machine to work on next for our maintenance person, or, you know, which product lines do we need to focus on more from sales, which, you know, how do we integrate and how do we, you know, from a manufacturing standpoint, reinvent how we create those, because we're going to be going after, you know, trying to increase sales volume there. And so therefore, you know, all those different things, they all relate to each other and they're all driven by data. That's really the goal of what we're trying to do, is use data to make every one of those decisions.
All right. All right, next slide. So just to remind everyone, the webinar coming up on the 25th is actually, Kurt's going to be talking mostly there. He's going to be talking more about the details of exactly what they went through to implement data-driven manufacturing and exactly what the results have been. So much more detail what you've heard already here. So again, we in this first part, we described what the process was, and now with this second webinar, you're actually going to see how it was physically implemented and all the issues that Kurt went through to do this.
Very good. I tell you, next week when we have Kurt on the hot seat, I'm sorry, when he's the main presenter, it really is going from concepts to reality. And so we're going to have a good discussion with Kurt about what it really meant in his organization and the steps they went through, the trials and the tribulations, et cetera, of what it's really like on the plant floor to implement different technologies. So we hope to see you all at the next week's sessions. I want to thank Kurt Schron at Juergens. I want to thank Rick Earls at Team Neo. And we want to thank all the members of the Smart Manufacturing Cluster that come together in our community to help put this all together. Once again, I do want to let everyone know that we will be posting this onto our Manufacturing Works YouTube channel, so you can refer back to it. And we do look forward to seeing all of you with us next week, same time. Thank you very much.